shock waves and the sonic boom. If a sound source, is moving faster than the wave speed in a medium, waves cannot keep up with the shock wave that is formed. Let's look at these pictures. In the first case, we have an object that's stationary, and the waves propagate out in every direction. It's interesting the wave spacing is similar everywhere. Therefore, if you were to stand at various locations around that, you would observe the same pitch. If an object is moving slowly, let's say at subsonic speeds, below the speed of sound, we observe Doppler. If I'm standing in front of it and it's moving to the right, I'd hear a high frequency. If I stand over here, I'd hear a relatively low frequency. If the object is moving at the speed of sound, it's chasing the waves that it's producing, and those waves pile up. And we get an area where crests pile up on crests. We end up with superposition, or a region of high pressure. Sometimes that's referred to as the sound barrier. Once we exceed the speed of sound, we can see that these waves were propagating out in every direction. Those waves again will interact with each other, and we get regions of high pressure along the leading edge of this cone. And the shape of the cone depends on how fast you're going. The faster you go, the more narrow that cone, or the smaller that angle is going to be. And this creates a region of high pressure, which is referred to as a sonic boom. Click here for the video on the sound barrier. It's quite interesting. Take some time to view that. Again, the concept of wave interference comes out to play in explaining how sonic booms occur. Shock waves and the sonic boom. Shock waves are analogous to the bow waves produced by a boat going faster than the wave speed in the water. If we were to look at these boats from above, we would see V-shaped waves behind each of these boats. That occurs behind ducks also. And the shape of that V, or how much angle is formed, let's call that theta, between those two waves, if you want to call them, or wakes, depends on how fast the boat's going. In the case of an aircraft exceeding the speed of sound in air will produce two sonic booms, one from the front and one from the tail. And a person standing at some location as the airplane goes by, as the first shock wave goes by, they'll hear or feel a rapid increase followed by a rapid decrease in pressure. They'll feel boom. When that second tail goes by, they'll experience the same thing. So in some cases, we'll experience sonic booms, one from the front and one from the tail.